By using one-sided limits, determine whether each limit exists. Illustrate your results geometrically by sketching the graph of the function. So here we have a function limit x squared minus 1 where x approaches 1. So the function is x squared minus 1 divided by absolute value of x minus 1 where limit x approaches 1. So let's try to do this problem and find the limit when x approaches 1 from left side and from right side. So first let's find from left side, that is limit x approaches 1 from left side means minus. In that case, this function can be written as x squared minus 1 over. If it is left of minus 1 minus side, then the denominator is going to be minus of x minus 1. That is kind of important, right? And now you can factor numerator and get your result. So we get limit x approaches 1 from negative side, and the numerator is x plus 1 times x minus 1, and the denominator is minus of x minus 1. And these two cancel out, they are common factors, correct? And so we get minus of x plus 1. And when you substitute, limit x approaches 1 from minus side. So when you substitute 1 here, you get 1 and 1 when you add is 2, and minus gives us minus 2 as our answer, correct? So we get limit of this function when approaching from left side is minus 2. Now if we do the same thing as limit for x approaching 1 from the plus side, in the numerator we can factor this out, x plus 1 times x minus 1, and the denominator is going to be x minus 1. Now when x minus 1 cancels, you get limit x approaches 1 from positive side of x plus 1. And when you substitute 1 here, then we get plus 2. Now as you see, the left side limit is not the same as the right side limit, right? Therefore, the limit does not exist. So we say limit does not exist. Why? Because left side limit is not equal to right side limit. That is why limit does not exist. Now we'll try to sketch this and show you, right? So what we found here is basically, now let me write out the function here. So we could write this as limit x approaches 1, and the numerator is actually x plus 1 times x minus 1 over absolute value of x minus 1, correct? So what we found is that when you are on the right side, then we get x plus 1. But when you are on the left side of 1, then you get minus of x plus 1, correct? So if we try to sketch this graph, let me squeeze in a graph here itself, then what you find is that there is a discontinuity at x equals to 1. So let us say this is our point 1, right? So when we are approaching 1 from left side, we get to a value minus 2. So we get a value, let's say this is minus 2, right? Minus 2. So we get a value at minus 2, and so there is a hole at minus 2. Now if we are approaching 1 from the right side, then we get to plus 2. So there is a hole at plus 2. Since the function, we cannot write 1 here because 1, the function is not defined, correct? At 1, the function is not defined, so get 0 in the denominator, correct? So we have a hole here. But when you're approaching from the plus side, the equation is x plus 1. So here the graph will be like this, correct? And in this side, it will be like this, going through this. Correct? Because the equation is minus x minus 1. Correct? So that is how the graph is going to be. So this is how we can write fy equals to x plus 1, and here it be y equals to minus x minus 1. So that is going to be the graph, and clearly the limit does not exist. There is a jump discontinuity in this particular case. I hope you understand and appreciate it. Thank you.